schedule. Let me introduce the next speaker, who is Fitsum Tadesse. His talk is about the contribution of asymptomatic and symptomatic infections to the infectious reservoir of Fitsum and Virax malaria in Ethiopia.
Good morning, everyone. I'll be presenting results from recent studies we have been undertaking in Ethiopia for the last 3 years. And we were trying to investigate the relative contribution to the infectious reservoir of Plasmodium vivax and Plasmodium falciparum infections in low endemic setting in Ethiopia. In the recent decades, we witnessed a substantial reduction in malaria in most endemic countries. Ethiopia has been historically low endemic setting, but it has recorded a massive decrease in malaria infection in the last decade. But in low endemic settings, where there is a plan for malaria elimination, there is an increasing burden from asymptomatic infections. The studies are indicating that as transmission intensity decreases, the proportion of infections which are undetectable by the conventional diagnostic procedures like microscopy and RDT becomes lower, and most of infections become low density. And results are indicating from high endemic settings in Africa that these infections are, these low density infections are important as contributors to the infectious reservoir to mosquitoes and subsequent transmission to the next host. But in low endemic settings, such as in Cambodia, studies indicated that only high density infections are relevant. But the studies in high endemic settings in Africa indicated that low density infections are important. This might be because of vector competency or other factors that can differ between the two settings. The same reports have been, similar studies have been undertaken for vivax as well. But what's lacking from these studies is the relative infectivity of these low-density infection carriers to the infectious reservoir compared to clinical patients in the overall context of their proportion in the population. So in Ethiopia, we have undertaken a few cross-sectional studies to evaluate the distribution of these low-density infections, and the study areas differed between 600, 400 meters above sea level to 2,000 meters above sea level. And we found a substantial proportion of infections which were only detectable by PCR. The microscopy detectable infections among the healthy community ranged from 0 to 26% in an area which is bordering South Sudan, which is really lowland, and you find only falciparum infection in there. But in other settings, midland to highland settings, we found really high proportion of infections which were only detectable by PCR. And the infections were highly heterogeneous. They were highly heterogeneous across different settings, and they are seasonal and unstable. We are undertaking dynamics study in few of these sites, and we have seen they are really unstable. And in Ethiopia, unique to all African settings, we have really high burden of vivax, which is ranging from less than 10% to 80% as you go up in the altitude. We focused on one of the study sites, which is in the central part of the country, and we assessed the distribution of the infection in different age groups and among the community. And in that study, we have included close to 900 individuals, and we found 8% RDT detectable infections among the healthy community, but the PCR detectable infections were 22.6%. Children less than 15 years old were the most affected, and vivax infections are the highly prevalent ones in the earlier age. And the density of infection is also very high among children. And we also checked for their distribution in the community, and we followed patients, and we have seen, we investigated the malaria prevalence around those patients and around control case, and we found these infections really clustered around only RDT detectable infections. For instance, for falciparum, the risk of having qPCR detected infection was, the risk of having PCR detected infection was 28.8-fold in households with RDT detectable infections than in households without RDT detectable infection. And these infections were found in households which were closer to water bodies and in households with eave openings and in individuals who were involved in outdoor activities. Then what we next did was to investigate the relevance of this infection. We proved that they are highly prevalent in the country and they cluster around a clinical case. Then the next question was to assess their real relevance in their contribution to this mosquito infection. Then we have undertaken another study, and in this study we included clinical patients, and we recruited them from government clinic, and we included 490 people from the healthy community, and we have taken samples for screening purpose, and microscopic results were available within 2 days, and PCR results were available within 2 weeks. So we included 41 patients from the clinic, and among the 490 people from the community, we found 42 individuals having microscopy detectable infection and 98 more only detectable by PCR. And we have done feeding using locally reared 2 to 6 days old Anopheles arabiensis mosquitoes, and close to 9,000 mosquitoes were fed. And feeding was done the same day for the patients and the next day on average for the asymptomatic microscopy detectable infections. And within 15 days for the PCR detectable infections. And infectivity to mosquitoes was assessed using CSP-based ELISA and finally confirmed with 18S-based qPCR on mosquitoes that were maintained for 10 days. And these figures are indicating the parasite density by 18S-based qPCR in vivax and falciparum infections. And these are the 3 groups: the patients, the asymptomatic microscopy positive ones, and the PCR detectable community members. And as you can see, there is a strong density difference between the 3 groups for both infections. And shown in the lower graphs is association between gametocyte density detected by PVS25 transcript for vivax and PFS25 male and female transcript for the falciparum. And we have seen that most of the infections are positive for gametocytes, like 96% for vivax and 84% for falciparum. All qPCR detected infections were positive for gametocytes. And we have seen a strong association between parasite and gametocyte densities for vivax. But for falciparum, we couldn't find association between gametocyte and parasite densities when both are measured on samples from the same time point. But when parasite densities were measured on samples from screening and gametocyte densities from samples from feeding moment, we have seen association. This reflects the late time that's required for the maturation of the falciparum gametocytes. But in vivax, there is early commitment, so you see the association. So the gametocyte density in falciparum was not associated with the parasite density from the same time point. So we had 2 time points during the study, the screening and the feeding. And when we have compared parasite densities measured during the 2 time points for vivax and falciparum, and this is the microscopy detectable infections, and these are the PCR detectable infections, we have seen substantial fluctuation in parasite density and detectability between infections. For instance, out of the 68 vivax detected infections during screening, 20% of them were lost during feeding, around 16% for falciparum. And of PCR positive infections during screening, 4 were found to progress into the microscopy detectability, and 7 falciparum infections became microscopy detectable. And some of these infections were found to infect mosquitoes. And this is the infectivity data of all PVivax infections fed to mosquitoes. 33% of them were found infecting at least one mosquito, with an average of 18% of mosquitoes being infected, and the infectious individuals infected 49% of the mosquitoes fed. And from falciparum infections, the infectivity was relatively sparse, and only 14% of the individuals infected at least one mosquito. And we also assessed for mixed infections, which I was not able to include in here because the table was so big. And when you look at Vivax, most of the infectivity was from either symptomatic microscopy detected individuals or asymptomatic microscopy detected individuals. But for falciparum, the asymptomatic individuals were the most contributors to mosquito infectivity. Shown in here is comparison between percent of infected mosquitoes in the y-axis and parasite density for Vivax and gametocyte density for Vivax, and the same for falciparum. And infectivity for Vivax was strongly associated with both parasite density and gametocyte density. But for falciparum, as you have seen it in the previous slide, the infectivity was lower, and for those individuals who were infectious to mosquitoes, we couldn't find association with total parasite density, but the infectivity was associated with both male and female gametocytes. Okay, the detectability and the relative contribution to the infectious reservoir of the three groups was determined by calculating the proportion of infected individuals in each infection category that are detectable for a range of diagnostic thresholds. And these diagnostic thresholds were determined by calculating the probability of detection by microscopy with regards to the PVivax 18S copy number. And then we found three detection thresholds with 95% confidence interval, 95% probability of detection, 80% probability of detection, and 50% probability of detection. And with the 80% probability of detection, which is around 584 18S copies per microliter, all the clinical case can be picked with that diagnostic threshold. And the densities differ between the three groups. The relative infectiousness of these three groups gains importance when we consider their relative prevalence among the total population. So what we next did was we got data from we got data local data from the district and also national data from the MIS, the malaria indicator surveys, and the expected proportion of infected individuals in each of these three groups was estimated based on the data we got from the incidence data we get from those source, and for the clinical patients, I mean, but for the asymptomatic individuals, we used our own data. So when you include this one in your estimate, you find that the proportion of the infectious reservoir, the proportion of the infectious reservoir changes when you look at it in terms of their prevalence in the population. So based on the estimates, the symptomatic individuals contribute only towards 5% of the infectious reservoir, but most of the infection is coming from the asymptomatic individuals, even if they contribute less in case of PVivax, owing to their high prevalence among the community. Estimates always come with uncertainty, but when we include when we include the upper limit of clinical incidence in this low endemic setting, still we find asymptomatic individuals contributing high to the infectious reservoir. As it was shown in the previous slides, the infectivity for falciparum was relatively low in that setting, and most of the infections are caused by asymptomatic individuals. So the asymptomatic individuals are contributing significantly in this low endemic setting. So this takes me to the conclusion slide. So in this low endemic setting in Africa, where you have Anopheles arabiensis as a vector, you find asymptomatic infections contributing significantly to the infectious reservoir. For Plasmodium vivax, from the preliminary data, it seems that microscopic infections are contributing significantly. But when we adjust for population prevalence, the asymptomatic category is the most important one. For falciparum, the asymptomatic individuals contribute substantially, as it was indicated in other African settings. And the other observation from our study is detectability fluctuates substantially over time. And then we conclude that early identification and treatment of asymptomatic infections might accelerate elimination efforts by cutting the number of days these individuals will be infectious to the community. With this, I would like to thank all contributors to this work. I was working for my PhD under the supervision of Ton Bassema and Robert Sauerheim from Nijmegen and Chris Drackley from the Netherlands. And I'm happy to take questions.